In this problem, I'm going to do classwork 3.2, number 8. This is a really good example of just a basic vertical circle problem. So you have a ball, and it's being rotated on a string, and it's in a vertical circle, so we can see the free body diagram here for each situation. The circle is 85 centimeters, the speed is 4.15 meters per second, and its mass is 0.3 kilograms. It says calculate the tension in the string when the ball is both at the top and at the bottom. Okay, so at the top we can see that the forces act together, and at the bottom they act opposite of one another. So I'm actually going to redraw this just so I can, draw it myself and sort of get the idea in my head, right? So up at the top we have gravity acting down, and then we have the string pulling down. Okay? At the bottom we have gravity acting down, but now we have the string pulling up. Okay? So the sum of all forces equation is that this plus this is equal to mv squared over r. Okay? Remember, we're looking for what causes this centripetal force. So up here we have Ft plus mg equals mv squared over r, and down here we have Ft minus mg equals mv squared over r. Okay? Now I want to solve for tension. It's asking me to solve for tension, so I'm actually going to subtract mg here, and then I'm going to add it over here. Okay? So we can just see from that what's going to end up happening is here we're going to have a smaller tension than we do down here, which makes sense because here tension is having to overcome gravity in order to maintain the net force in this direction and maintain the velocity, whereas here tension gets to work with gravity in order to spin this object. Okay? So now we just have Ft is equal to, and the mass of the ball from the problem was 0.3 times 4.15 squared all over 85 centimeters, which would be 0.85 meters, minus 0.3 times 10. Okay? And then down here, we would have Ft is equal to 0.3 times 4.15 squared all over 0.85 plus 0.3 times 10. Okay? So all we have to do is plug this in. Let me zoom out just a little bit. Okay, so we get, let me put it where you can actually see the numbers on my calculator. So we get 0.3 times 4.15 squared equals divided by 0.85 minus 3 gives us 3.08. So the force due to tension up top is 3.08 newtons. So up here, 3.08 newtons equals Ft. Now down at the bottom, so here I'm just going to add 3 back. Down at the bottom, this is what we get for here, and then we're going to add 3. Right? Let me just do that again, just so we can see. Times 4.15 squared, and then divided by 0.85, and then we're going to add 3 to it. So at the bottom, it's actually 9.08. So the force tension at the bottom is 9.08 newtons. So down here, it's 9.08 newtons.